In this lesson, we want to look at the limiting reactant. These are probably the most difficult questions that we come across in our course. So we want to take some time to make sure that everybody can follow through with the process for answering each of the different types of problems. So remember that in a chemical equation, you're going to start with a couple of reactants. And usually you don't start with the same amount of each reactant. Usually one of them is there in an excess amount, one or more, and the other is there in the limiting amount. And the limiting reactant always determines how much product you have. So we need to remember then that the limiting reactant here, limiting reactant is always used up in a reaction. And then that means, of course, that the one that's left over, the excess reactant, some will remain or be left over, however you want to think about that. Okay, and when we look at this activity in class, usually we make s'mores in class, but we can't do that obviously virtually. So let's just use that analogy of the s'mores to try and refresh your memory about what a limiting reactant looks like. So of course, there's a lot of analogies here to recipes. So if we are making s'mores, we would need a recipe, and in chemistry that would look like an equation. Let's say we need 1 part chocolate and 1 part marshmallow and 2 parts graham cracker to make ourselves a chocolate marshmallow graham cracker mixture that we call a s'more. So if you were rummaging through your cupboards to find ingredients to make s'mores, let's say for example you locate say 8 squares of chocolate and 6 marshmallows and 10 graham crackers. Okay, I'm just going to get rid of that plus sign there because it's not really an equation, it's just our amounts. Okay, so if you follow the equation, which is like a recipe, you're going to be able to make a certain number of s'mores, and whatever you have that limits that particular recipe, that would be in chemistry called the limiting reaction. Whatever's left over, that's called the excess. All right, so let's try and figure out how many s'mores. So if we wanted to use all 8 chocolate, okay, here, so if we wanted to use all 8 chocolates, since these are 1-to-1, we would need 8 marshmallows. So right away, if we're just considering the first 2 ingredients, we can see that the number of marshmallows is going to limit the number of s'mores we can make. We do not have the ability to make 8 because the marshmallows will limit. Okay, so right now, we could make 6 s'mores with 6 marshmallows. We'd have 6 chocolate and we'd have a couple left over. Okay, so let's assume we're going to make the 6 s'mores. It tells us in our equation every s'more needs 2 graham crackers. So 6 times 2 is 12. We would need 12 graham crackers, but we don't have 12 graham crackers. We only have 10. So our answer then, in terms of how many s'mores can we make? Well, we know that there's a 2-to-1 ratio of graham crackers to the other. So 10 divided by 2, we could make 5 s'mores. Okay, so the graham crackers then are called the limiting reactant, and I'm just going to use the short form LR. And we're going to have 2 excess reactants here. If we make 5 s'mores, we would have 6 marshmallows, we would use up 5 marshmallows, and we'd have 1 marshmallow excess. Our 8 chocolate would still use 5 chocolate, and we would have 3 chocolate pieces excess. So I want you to keep that kind of analogy in your head as we try to go through some of these sample problems. We're going to start with the easiest ones, obviously, that makes a good starting point, and then just kind of move up from there. All right, so our first sample problem. You'll see here that a lot of your previous knowledge has to come in play to do these questions. There we go. Sorry, something happened to the screen. Okay, so we're going to calculate the limiting reactant and excess reactant when 0.28 moles of magnesium reacts with 0.26 moles of oxygen to produce magnesium oxide. All right, so what kind of steps? I'm just going to keep a little record over here of the steps that we need to do this. And step one, almost every time in chemistry, no matter what you do, you need to have a balanced chemical equation. Okay, so this is where your grade 10 and previous units from grade 11 information comes in. We need to go back to the question, and we see that we are using magnesium. Okay, so we're going to write down magnesium, and that comes as a solid. Don't worry about the states of matter yet. We're going to learn that in another unit. And then, of course, we're going to react it with oxygen. Okay, so here's our keywords. Magnesium reacts with oxygen. And if we remember Hofbrinkel, we know that oxygen is always a gas, okay, and it's a diatomic gas, so it's going to it's going to exist as O2. And then we're going to make magnesium oxide. How do we know that's the formula? We got to remember back to previous units, the valences of these two crisscross and cancel out, okay? Just get rid of that because it's not part of what we need. All right, so let's balance this up. We've got 2 oxygens on the left, so we need 2 oxygens on the right. We've now got 2 magnesiums on the right, so we need 2 magnesiums on the left. And so we now have a nice balanced equation. Okay, so the next thing that I want to do is just kind of write down the information that's given from our question. So we've got, if we go back to our question, 0.28 moles. So I'm just going to write that underneath here of magnesium. And it tells us we have 0.26 moles of oxygen. Right away, let's have a look at this question. It looks different than the ones you saw before, because if we were doing just a straight mole-to-mole question or a mole-to-mass question, we would only be given one value, like maybe just this value, and when we could just take that and use it. When you see there's a quantity for each of the reactants, you must go through the process of figuring out which one is limiting and which one is excess. Okay, so let's go through and see what we need to do. All right, so in step 3, we're going to do what we call the mole ratio. And so in the video you watched the other day, you saw that you could do a mole ratio just by multiplying by a certain factor, or you could do the conversion factor where you'd have like moles of oxygen and moles of magnesium, and you'd be canceling out like this. Okay, any method that makes sense to you is the method you should be using. All right, so for me, I always like to work with algebra and ratio. So I'm going to show you the way that I do it, and again, you can use any way that you like. So in my mind, I kind of visualize making this into a little ratio. So I'm going to say, okay, I've got 2 magnesiums over 0.28 moles. And I'm going to set up a ratio with the oxygen here. Remember, when there's no number in front, that's like a 1. So what this is telling me is that if I want to use up all of the 0.28 moles of magnesium, then how much oxygen would I need to go with it? So again, I'm going to cross multiply, and so just removing the element symbols, the 2x then is going to be 1 times 0.28, or 0.28 moles. Oops. So x then is going to be 0.28 divided by 2, which is 0.14 moles of oxygen needed. All right, so now we can just, we wouldn't need to write down all this, but I'm just going to write it for the sake of something you can come back and have a look at. If we go back to our equation, or to our question, sorry, we have 0.26 moles of oxygen. Okay, so we have excess, more than we need, or excess. As soon as you figure out which of our reactants is in excess, then the other one is limiting. Okay, so now we could even ask ourselves, well, how much excess do we have? Well, that's a fairly easy question to answer. The question told us we were given 0.26 moles. Our ratio tells us to use up all of this, only need 0.14 moles. So therefore we have 0.12 moles excess. Okay, so make a little therefore statement. Therefore, magnesium is limiting. There's lots of other questions I could ask you about this, but I just want to make sure that you're understanding kind of the simplest bits there. Okay, so let's try another problem that introduces just one more step. So sample problem number 2. And if you remember before, when you're looking at a balanced chemical equation, only moles can be used in a balanced chemical equation. Only moles can be used with balanced chemical equations. That's basically by definition what stoichiometry is. I'm going to run out of space there. Short form for equation. Okay, so in this question, the question is going to give you mass, and one of the key things you have to remember is that mass cannot be used directly in an equation. So let's start with the question. Remember, that stands for calculate the limiting reactant and excess reactants when, now we're going to start with a mass here, 27 grams of aluminum and 4.05 grams of chlorine react. Okay, so let's remember our steps. What do we always do? We always need a balanced chemical equation. I'm going to keep that over here, balanced chemical equation. All right, so we've got aluminum, and we're going to react that with chlorine. Once again, we've got a gas, that's a Hofbrinkel gas or a diatomic gas, and we are going to make the product. Now notice in this one, a little extra trick, it doesn't tell you what the product is. So again, you need to go back to your periodic table. You find out that aluminum is +3 and chlorine is -1, and you're going to crisscross those, okay, and discover that our product in this case is going to be aluminum chloride, and that'll be a solid as well, and it looks like that. Okay, so we got to balance it up. 2 chlorines here and 3 chlorines over here. We'll go for a common denominator of 6, and that puts 6 on both sides, and then we just need to add the 2 here, and then that should be fine. Okay, so that's step 1. Step 2, same step 2, we're going to just gather our given information. I like to put it right underneath what we've got here, and we know we have 27 grams of the aluminum and 4.05 grams of chlorine. Now, remember, we must find the moles. Grams cannot be used in a mole ratio. Okay, so that's the new step here. We must find the moles, so let's make that step 3. And I always say, every time I'm teaching chemistry, if you don't know what to do, then find the moles. By the end of the course, we'll have 6 different ways to find the moles, and in every single problem that you come across, just figure out how to find the moles, and you'll usually be more than halfway there. Okay, so to find the moles, what do we need to do? We're given a mass. So the moles of aluminum will be mass, problems with my screen again, mass over molar mass, which will be 27 grams over the molar mass of aluminum, 26.98 grams per mole. Cancel out those units, and we'll have 0.1 moles of aluminum. And we'll do the same thing over here. We're going to find the moles of the chlorine. It's going to be mass over molar mass, which will equal 4.05 grams, over the molar mass of 2 chlorines, 70.9 grams per mole. And that gives us 0.06 moles of chlorine. Okay, so now we're at the same point we were with the other question. So now we just have to work with our mole ratio. So you could pick either of the reactants. I usually just start with the first one and do the math for that. So in my mind, I'm going to say, let's do our step 4 mole ratio. So to use up all the aluminum requires how much chlorine? Okay, and I'm just choosing aluminum because it's the first one. If you want to start with chlorine and work the other way, you can, no problem. Okay, so what am I going to do here? I'm going to go back to my equation. I'm going to say 2 aluminum, and I've got 0.1 moles of it, remember, so back to the equation, and then here's my 0.1 moles, and I'm going to make my ratio to use up all of that. I know I have 3 Cl2s, and I wonder how much chlorine would I need. Okay, that's my question mark or my X. So again, I'm going to cross multiply 2x, I'm going to cross multiply in the other direction, equals 0.3 moles. So therefore, X would be 0.15 mole of chlorine. All right, so now what I need to do is go back to my givens. Okay, so I look back up here and I say, we only have 0.06 moles of chlorine. That's not enough. Okay, so that's like saying we didn't have enough chocolate or marshmallows. Whatever the not enough is, in chemistry, we call that the limiting reactant. Okay, so if Cl2 limits, so therefore Cl2 limits, or is the limiting reactant, then we can say aluminum is excess. Okay, some questions might say, how much excess? All right, so just depending on what the problem is asking you, how much excess aluminum? Okay, so that's fairly straightforward to figure out. You can go back and use the ratios again. 2 aluminums, 3 chlorines. Where are we getting that? From our equation. This time we're going to say, all right, let's use up all the chlorine. Okay, because we know that the limiting reactant is always used up. Okay, so let's use up all of this and see how much we have left over. So 3x will equal 0.12. X will equal 0.04 moles of aluminum needed for that reaction to go. And we started with, what was that number again? 0.1 mole. 0.1 moles of aluminum. So 0.1 mole minus the 0.04 mole would give us 0.06 moles of excess aluminum. Okay, so hopefully that kind of gives you a third way to go through and figure out how to solve these limiting reactant questions. We're going to do lots of practice, and practice makes perfect, and hopefully we'll get through this kind of difficult sort of problem together. All right.